ранок. Так, давайте починати. Рада всіх бачити. Так, share screen. Зараз. Пам-пам-пам. Да, думаю, що можемо. Чи видно мій екран?
Так, видно.
Так, значить, давайте ми сьогодні будемо... Запис.
Recording in progress.
Сьогодні ми з вами будемо говорити про деплойменти в Kubernetes. Ну, тобто, там є така структура деплоймент. Просто в нас є deployment challenge, а тут ми ще будемо казати про деплоймент в Kubernetes. Далі ми будемо говорити, ми перейдемо до іншого челенджу. І той челендж буде про Service Discovery. І ми подивимося на сам паттерн, і цей паттерн можна досягти, можна реалізувати двома способами – інфраструктурним і application level. Сьогодні ми почнемо з infrastructure level approach. Application level approach я покажу вам наступного разу. Ну, ось такий план на сьогодні. Тобто закінчуємо deployment challenge. І це буде Kubernetes Deployments. І беремо новий челендж. Ось такий план на сьогодні. Так, буде трошки відосиків. Ну, тобто, поки ми будемо дивитися Kubernetes, у нас будуть відосики. Потім, як ми закінчимо Kubernetes, то відосики закінчаться теж. Буде вже лекційний матеріал. Так, давайте. Так, значить, наш фокус саме на deployment концепт. І тут буде багато цікавого. Значить, минулого разу ми дивилися на поди. Под як одиниця, але под нам не дає такої важливої частинки, як high availability. Deployment нам дає high availability і ще багато чого. І от сьогодні ми зараз про це і дізнаємося.
Earlier in the course, we used the kubectl run command to actually...
Не чути, давайте я перешарю екран. Я звук не розшарила. Share sound. Тепер має бути чути. Що?
Був звук.
Був звук, так? Да? Ух ти. Угу. Цікаво, я галочку не поставила, а звук був. Буду знати.
Get a pod up and running, but it did more.
Так, гаразд, правильно?
Так, чутно.
Дякую.
Than just that. It also created a deployment and a replica set. So in this section, we're going to focus from a higher level on what exactly are deployments and replica sets. A replica set is nothing more than a declarative way to manage the pods. Think of it as kind of the boss of the pods that sits behind the scenes to make sure that they're working efficiently, and if one of them gets sick, we can get that replaced. Now, a deployment sits up at a higher level, kind of wraps a replica set. It's also a declarative way to manage pods, but it uses replica sets under the covers. So in the evolution of Kubernetes, replica sets came before deployments. Then deployments came out, and they kind of wrapped and simplified the overall functionality. From a pod perspective, we know that pods represent the most basic resource in Kubernetes, and they can be created and destroyed, but are never recreated. So what happens if a pod is destroyed? That's where deployments and replica sets are there to ensure that we have the correct number of pods that are running. We talked early on in the course how Kubernetes is about you give it the state that you want. I want 5 pods, I want 10 pods, whatever it may be, and it just magically makes it happen. Deployments and replica sets play a big role in that, and if a pod does go down, that's where these are going to step in. Now let's first talk about replica sets. So looking at the image here to the left, you can see that a replica set is going to really control the pods. A replica set's job is, first off, it can act as a self-healing mechanism. And we've seen that if you delete a pod with a replica set or deployment behind it, then it can just magically bring it back to life. And I use the term magically a lot because having worked with applications a lot over the years, and I'm sure you have as well, what happens normally when something goes down? You're kind of out of business. You probably have some logging, hopefully, and you have to go figure it out. Well, that's kind of the beauty of Kubernetes with replica sets, deployments, and pods, is we get some help here when things do go down. Now, another thing replica sets do is they make sure that that state we're trying to achieve is met. If we want 5 pods, it wants to make sure there's 5 pods. It also provides fault tolerance. That ties into the self-healing, actually, and replica sets can be used to scale our pods horizontally. So if you currently had 2 and you want to move that out to 4, then you could do that with just a simple command, actually. Now, it does rely on a pod template, and we're going to be seeing that in a moment, and you're going to see it relates to what we covered in the previous module when we talked about YAML. So as a result of this, there's no need to create pods directly. We're going to use deployments and replica sets to do that. And as I mentioned, replica sets are actually used by deployments. Now, the way this works with a replica set is once you have one created, it will ensure that the desired number of pods are created. So in this case, 2 pods. Now, you'll notice on this replica set that our desired was 2, our current number of pods is 2, and we have 2 that are ready. So we're obviously in an optimal situation. This is what we'd want. When it comes to using these and maybe a pod goes down, gets replaced, replica sets will make sure that we stay at that desired level. Now, how do deployments fit into this process? Well, they're really just a higher level wrapper around replica sets. Replica sets ultimately use controllers to control the pods. Deployments make that process even easier. So a deployment is responsible for managing the replica sets, and it will use those to scale the pods, as I mentioned earlier. Now, one of the most powerful things about deployments and replica sets is this zero downtime updating of your applications. Normally, if we update an app, unless you have a separate environment that you switch over to, then the original app might be down for a little bit while we do that update. Well, I'll show you there's several ways we can do deployments in Kubernetes where we don't have to take the application down, and there's other benefits we'll talk through as well. Now, another thing it supports is rollback functionality. Let's say you rolled out an app and deployed it using a deployment and replica set, and something went wrong. Well, you can actually roll back to the previous one if you'd like. Earlier, when we talked about pods and YAML, I briefly introduced the concept of labels, and I mentioned we're going to use these later with things like deployments, services, and other resources in Kubernetes. So we're going to see how labels actually can kind of hook, if you will, or join a deployment with a pod template. And then finally, the YAML for a deployment looks very, very similar to a replica set. One of the big differences is the kind that's defined. What's nice there is if you saw a replica set demonstration out on the web somewhere, you could actually just take that and quickly move it into a deployment if you'd like. Very easy to work with. So now that we've taken a high-level look at deployments and replica sets, let's see how we can officially create a deployment using YAML.
Тут я хочу додати декілька таких пояснювальних речей. Тут дуже важливі речі є, окрім такого скейлінгу, ось high availability, тобто це мінімум 2 там репліки, плюс скейлінг – це додавання більшої кількості подів. Тобто тут вони звучать дуже нецікаво, ну, тобто не яскраво. Цікаво, але не яскраво. Але за цим стоять дуже потужні речі. Оце саме high availability та scaling, ну, потужна річ. Далі zero downtime deployments. Тобто, щоб користувач не бачив, що ви взагалі деплоїтеся. Далі rollback. Це теж дуже цікава штука, дуже потужна штука. В тому плані, що якщо, ну, ви розумієте, що щось пішло не так, не може, ну, тобто ви викатуєте нову версію оновлення, але щось іде не так, і ви можете відкатитися. І ви можете відкатитися на попередню версію. І це робиться, ну, тобто, автоматично. Тобто нова версія не стартувала, окей, користувач того не помітив, ви залишаєтеся на старій версії. Тобто ці три потужні штуки, ну, насправді вони дуже потужні, вони дуже, ну, такі, я навіть не можу підібрати і підійти цієї потужності. Окей, давайте йдемо далі.
Deployments are really where a lot of the fun of Kubernetes started for me when I first learned it years ago. And that's because of the really powerful features that they offer, from the making sure the pods stay up and running, to rollbacks, to different types of deployments. But before we get into all of that, how do we create a deployment? Well, we're going to use YAML again to declaratively do that. So the nice thing about deployments is you don't have to create the replica sets that are going to run behind the scenes. They handle making sure we have the required number of pods. Deployments are a higher level wrapper, as mentioned, and they'll take care of that for us. To create a deployment, we're going to write a YAML file, very similar in structure to what you've seen up to this point. And then we're going to use kubectl to either create or apply that YAML file to get that deployment and the underlying replica set going. Here's what a deployment YAML file looks like from a high level. First off, you'll notice we have an API version. In this case, it's apps/v1. One of the things I struggled with when I first got into YAML was, how do you know what to put there? And the answer is you go to the docs and you look it up, or you just find a good sample out there. Now, the next thing you'll notice is the kind is a deployment. Well, earlier when we did pod YAML, we said kind pod. If we did a replica set, it would be kind replica set. But because deployments wrap replica sets and create those under the covers, we can just say kind is a deployment. And we can also have metadata. What's the name of this? Does it have any labels? Things like that. And then we get to some stuff that we've seen somewhat up to this point from the pods module. We have a spec, and then if you look down a little lower, another spec. What we're doing here is we're defining the overall deployment spec, and the selector that you see is going to select the template to use. Now, the template normally is going to be right below, although it could be in a separate file. For the demos I'm going to be showing, and in real life, I like to keep those together to kind of minimize the number of files that I have. So I'll show you the selector coming up shortly on kind of how that's used, but ultimately that's going to select the template that has the pod spec. That's the other spec that you're going to see right down here. Now notice this is what we covered earlier in the pods module when we looked at YAML. We have the containers, we have the name that we want at runtime of the container, and we have the actual image, in this case, Nginx Alpine. Now that you've seen kind of the high-level 10,000-foot view, we'll say, let's jump on into a little more detailed one. So we have our API version and our kind. You'll notice that we also have our metadata. Now, this metadata has a name for the deployment, but it also has labels. Now, the labels, again, first off, can be used when you're querying multiple resources. You could say, hey, go find everything that has this label. But labels can also be used to tie things together, and you're going to see that shortly with our selector that we're going to get to in just a second here. So let's jump on down to that. Looking at this, you'll see how the selector property has a match labels. Now, I only matched on one label, and the key or the name of that label is tier, and the value is front end, you can see. What that's going to do is if you look down a little bit lower, notice that in the metadata for the template, we have labels tier front end. So the template and the template spec that you see right below it is now going to be hooked to the selector for this deployment. In fact, any label out there of tier front end in a pod template even would be hooked to this deployment. Now, many people, as I mentioned earlier, including myself, like to put the template right in the deployment because it keeps it very easy to manage. But if you wanted to separate it out, you could do that, because the way Kubernetes works is when it sees a label of foo, and then over here we have label of foo, then it links those together. And that's done through this selector. So now when we go to run this deployment, it automatically selects the front end, tier front end. That goes down to the template that you see, and then that would start up our Nginx Alpine container. And it would make sure we get the self-healing, we can scale, we can do all that stuff that we talked about. Now, to show even further that this really is similar to a pod template, we can even put our probes into here for our pod health checks. So earlier in the pods module, we talked about probes. And here's an example of a liveness probe that has that HTTP GET. So while this is in the deployment, you'll notice that we're defining the entire pod template in this template map and the corresponding spec and containers and everything that you see here. So all that type of thing can be done to do our checks, and in this case, look for index HTML on port 80. So that's a quick look at some of the YAML you would define for a deployment. So now let's take a look at how we can put deployments to use with kubectl. It's time to move on to the next exciting step. We've looked at YAML, and now we want to take that YAML and use kubectl to start up our deployment. Now, the easiest way to do this is to use the kubectl create command that we've already talked about up to this point. And that would create that resource and get the deployment, the underlying replica set, and whatever pods are supposed to be running going on your Kubernetes cluster. Now, recall that we could also use kubectl apply, though, to create. I've mentioned I'm a big fan of this one because while we can also create, we can also use it to apply changes. Now, as a reminder, remember that if you use it to apply changes, and if you didn't create the initial deployment, someone else did, and if they use kubectl create, you'd want to make sure that everybody's using save config. For me personally, I pretty much just always go with kubectl apply, whether I'm creating or applying changes, but it really depends, because the nice thing about create is if that resource is already there and you didn't mean to override it and apply those changes, you would get an error. Whereas with kubectl apply, assuming they've done save config, if they did the create, then it would apply the changes, and you may or may not want that. So it's important to understand kind of the differences there and what you can do with these. To get deployments, we can simply run kubectl get deployment or deployments, by the way. A lot of these commands, you can use a shortcut version of the name. You don't have to type the whole thing. Now, if you want to show all the labels for the deployments as well, then you can do show labels. And we started talking about labels in this particular section. Now, labels, as you recall, can be used to tie things together, like a deployment to a pod template, but they can also just be used to organize things. You saw earlier I had a label tier front end. I might have tier back end. And I made up those names. The names and the values don't really matter. What matters is that when you're planning this, you sit down and discuss this either with your team, your Kubernetes administrators, whoever it is, so that you can organize this in a way that's going to be maintained. I think as a developer, it's really important to know at least the core concepts of Kubernetes at a minimum so that you can help out, because let's face it, who knows your app better than you? If you wanted to get deployments with a specific label, because oftentimes you'll have many deployments in a cluster, then you can use this -L for label, and that would then allow you to list the name and then the value of the label. In this case, app Nginx. Very, very nice, because now again, if I had, say, tier front end or tier back end as a label, I could say, hey, give me all the deployments for my back end. And it would list all those and filter. To delete a deployment is the same as what we've seen up to this point with something like a pod. We can just say kubectl delete, say deployment, and then the deployment name. Very simple. Alternatively, we can also say -f and give the path to the YAML file. Now, another thing we can do is we can scale. And this is something I mentioned earlier in this module when we introduced replica sets and deployments. And this is a great feature. So first off, there's a kubectl scale command. And what we can do is say, I'd like to scale a deployment, give the deployment name, and then what do I want for that pod template? Well, I want 5 replicas. In other words, I want 5 pods. And that will automatically scale that out to 5 pods. If you had a YAML file and you want to do it that way, you can also do -f again and give it that. And then we could scale it out. You can also put the replicas that when it starts you would like into the YAML. And so there's many different ways that we can scale out our pods. Very, very useful in the case of one of the pods getting a lot of traffic and you want to scale that out on a given node. And that's how easy it would be to do that. And we're going to play with that coming up here momentarily. So that's a quick look at some of the kubectl commands. Some of these we've already seen, such as kubectl create and apply. We've also seen delete, but you also saw a new one here, which is scale. In the previous section, you saw some of the different kubectl commands that we can use. So let's put those to practice and actually use them for real. So back in VS Code, I have nginx deployment.yaml file. Now I have all the normal suspects here. We talked about the API version, the kind, metadata, the spec. But the big thing I want to jump to is the selector. And you'll notice that I'm matching labels called app mynginx. Now we also have an app mynginx. That's going to be for the deployment itself. But if we look down, you'll notice that we have a label in the template called app mynginx. And that will tie the deployment to this template. Now inside of that, we also have our spec, which is our pod template, and then we have our container information. Now I've added a bonus feature here that I mentioned a little bit earlier in the course, but we haven't looked at yet. But it's definitely something you want to plan for. And you can see the property here is called resources. Now this allows you to basically constrain what a given container is allowed to run inside of a pod when it comes to memory usage, CPU, and things like that. In this case, I'm constraining the memory to be 128 meg max and the CPU to be 20% of the CPU. Adding these resource constraints is very important because I've seen several companies out there who have deployed to Kubernetes, not put these, and then they had kind of a runaway train, you could say, and that container ended up bringing down an entire node. So putting these constraints in place are important because that way it can automatically restart that container if it needs to, as that constraint might be hit on those resources. So that's a little bit of a bonus piece. Let's go ahead and you've seen the deployment. Let's go ahead and run it. And we've already talked about how easy this is. So we could do kubectl, or in my case, K, since I've aliased it. And we're going to do a create. Now I'm going to do a save config. All right, so that deployment's now been created. So let's do a get all. And there we go. You'll notice that we have our mynginx pod, which is up and running. We have a deployment called mynginx. That equates to the name that you saw up here. And then we also have a replica set called mynginx. Now notice it has a value here that actually ties up to here. And that's how they can associate the replica set with the pod or pods that are actually running. Some other things we can do that we talked about a little bit earlier in a previous section. If we wanted to go in now and describe the pod, we could do that. So we could go in and describe pod, but we can also go in and describe the replica set or the deployment. Now let's do the deployment, since that's what we're working with here. And it was called mynginx. And you'll notice that I can get some information. There's some of my resource limits. You can see right there, the image, the port. Here's my annotations from the save config that we did. And you get the general idea. Down at the bottom, you can see we scaled up to 1. And we can also get our deployments through kubectl get deploy. And you'll notice this actually works. Or deployment. Or deployments. You can kind of take your pick. Now, if you feel better about it, you can type it all the way out, either way. But we can also do this. We could say, show labels for the deployments. And you'll notice off to the right, the app equals MyEngineX shows up, and that was our label up here from our YAML. Now, if I wanted to filter, then we can do -L, show me the label app equals MyEngineX, and notice it brings back that one. Now, that's, of course, the only one I have right now, but if we had many deployments out there, then we could do something like this. Let's go back to everything again. So we'll do kget all, and notice that we have one of one desired. If you recall, we talked about there's a scale command. I'm going to show you 2 ways we can do this. First off, we can do kubectl scale, and then I'm going to give it my YAML file again. And then we could say, how many replicas do we want? Well, we want 4 replicas here. All right, so it says it's scaled. Now let's do get all. And there we go. We now have 4 of those Nginx pods up and running. So we've scaled horizontally. You'll notice if you look down at the replica set that we desired 4, we currently have 4, and 4 are ready. Now let's go ahead and delete this deployment. All right, it says it's deleted now, and watch what happened though. See, all these are now terminated. Now, once this is done, let me recreate the deployment and we'll scale it, but I'm going to show you a different way. Now, everything's gone, you'll notice. So I'm going to come into the YAML this time and say replicas is 4. Save. And this time, let's do an apply. All right, so my Nginx has been created. Let's do get all. And there we go. Notice I get the same effect as running the kubectl scale command. Let's say we just want 2 now. So I'm going to run the apply again. There we go. It's been configured, and then we'll do get all. All right, now 1 is terminating. The other one already has, apparently. And notice we have 2 running. Desired is 2. So in just a moment, in fact, it's probably done at this point. There we go. Now we're down to our 2 pods, and you can see I did that without running the kubectl scale. So you can drive it through the YAML, you can do it imperatively through the scale command. Really depends on what you want to do. Now again, with things like production, you want to be a little more careful. If I was using Kubernetes for maybe testing or just simulating a production environment, it's probably easier just to use the kubectl scale command. Very simple, we can run that right from our console like I'm doing here. So that's an example of how we can work with deployments using kubectl. So as a quick review, we did kubectl create, gave it the path to our YAML, and did save config so we get the annotations for updates. We can also describe a pod or a deployment with the describe command. We can either create or update resources using apply. And then we saw a few ways we can work with labels. I showed the -- show labels, but we could also grab a specific label. And if we had multiple deployments or pods or really any resource that you choose, then we could just pull those labels. From there, we did the kubectl scale and we gave it the number of replicas that we wanted. We also showed how we could apply those changes with kubectl apply by adding the replicas map, the property and the value into the YAML. So that's how you can get started with deployments and kubectl. While deployments help you get your pods up and running within your cluster, there's a lot of other things you can do with them as well. So we're going to talk about a few of those here. So let's say that you've currently rolled out a specific version of an image that's running inside of a pod, such as this Nginx 114.2 Alpine, and you'd like to move that forward to 115.9 Alpine. Well, normally, kind of in the old days, you'd have to stop the old container and then bring up the new one. There might be a slight downtime between those. So what deployments allow us to do is a zero downtime deployment. And this allows your updates to be performed without actually bringing down the older version of your application. Obviously, this is a very good thing. Now, this is a big topic, and we're actually planning additional courses just on deployments because there's a lot we could go into. But let's talk about some of the deployment options that are out there and how they can help us, especially as developers. So as mentioned, one of the strengths that Kubernetes offers is this zero downtime deployment. I'm going to show you how that works in a moment, but in essence, it can bring up new pods, and once those are running, kill off the old pods and reroute the network traffic and do all that for you. Now, it'll update those pods without impacting the end users, which means you don't necessarily have to do this in the middle of the night. And there's several different options available, actually. The default is called a rolling update, and we're going to talk about that more in this section. But you can also do things like blue-green deployments, or you might hear AB deployments, canary deployments, and you can even roll back. Now, blue-green is where you're going to have multiple environments running at exactly the same time, and then once you've proven that the new one is good, you'll switch all the traffic over to the new one. Canary would be where a very small amount of traffic goes to a new deployment, and then once that's proven out by the users hitting it, you can switch all the traffic over to that one. And then rollbacks would be, we've tried it, it didn't work, let's go back to the previous version. And that's actually something that's also possible. Now, as mentioned, we could go on for quite a while on these different options just right here. I'm going to focus in this core concepts course on rolling updates. And I'm going to show you a little bit visually on how that works. So let's say that we have this scenario here. We have 3 pods all running V1 of some application. Now, what will happen when you do a deployment with a rolling update is the new version of the pod would roll out to the production, but the old ones are going to still stay running. Now, once that new one is ready, and remember we have readiness probes and things like that we can use, then one of the older pods can be deleted. Now it just keeps proceeding from here. Now another pod can be created for V2. Once that's ready, it can get rid of the older one until it gets all the new ones in place, as you can see here. That's how a rolling deployment works, and that's why we can get a zero downtime deployment going. Now, the beauty of this is just by using kubectl apply and then giving it.
Я прерву, здесь есть у меня один комментарий. Я перерву, тут є один коментар в мене. Хочу звернути вашу увагу на те, що ось тут, в цьому сетапі, скільки одночасно версій сервісу працює? Да.
Дві.
Да, тобто і новий, і старий сервіс працює. І тут я хочу привернути вашу увагу до того, що дуже обережно треба відноситися до того, який API ви експозите. Бо якщо ви, наприклад, у вас є API, і ви його зробили breaking changes в одному і тому самому API, але в цьому, тобто, наприклад, при створенні юзеру ви почали вимагати нове поле, обов'язкове поле, а раніше ви його не вимагали. Але в цьому випадку, коли ви апдейтите, виходить так, що іноді реквест може прийти на будь-який под, і операція, наприклад, може спрацювати чи не спрацювати. Тобто я до того, що ось в цьому випадку у вас 2 різні версії працюють одночасно. Тому дуже, це не в темі нашого курсу робити там версіонування API і все таке інше, але все ж таки тут звертаю вашу увагу на те, що дуже уважно до того, щоб ви не ламали API, щоб не робили breaking changes в API. Добренько, йдемо далі. Ось тут десь зупинилися. Так.
Now, the beauty of this is just by using kubectl apply and then giving it your updated YAML, this automatically happens. It'll do this in the background, and it's something you really don't have to worry about a lot. Now, in just a moment, I'm going to show you an example of this, but from a development standpoint, the nice thing here is you don't have to write your code in any different way, shape, or form to make this happen. It's just a built-in part of how Kubernetes can do deployments. Again, there's other options you can do, and that's something you have to coordinate with an administrator if it's a production deployment. But even just playing around with a local cluster, you might even use some of these other options like an AB or blue-green or canary or things like that. So now that we've talked through what a rolling deployment looks like and how we can do these zero downtime deployments, let's take a look at them in action. Now that we've talked a little bit about zero downtime deployments, let's take a look at them in action. So I have a project here for a Node app open, and there's 3 versions of this app. Now it's a very, very simple app. It simply writes out the version of the app to the web page and also shows the pod that it's running inside of. Now in order to run these, I first needed to create the images. I have the Docker extension for VS Code installed, so I can just right click and go to the build image here. And then it needs to be named Node app 1.0, and then 2.0 and 3.0 for these different images. Now I've already done that, and so I have those images available. The next thing is I have 3 deployment files, you'll notice. They all have the same name for the deployment, and they all have the same overall template. Now they do change the replicas and do some things there, but you'll notice on the image, we're targeting Node app 1.0. Obviously the V2 would target 2.0 and then 3.0. Now, there's one little bonus feature I want to talk about before we run this, and that is this min ready seconds. This is a way to say we would like to wait for the pod to make sure that the container hasn't crashed for 10 seconds. And this could be useful in cases where when a pod first starts up, a container might crash and you would want it to be rescheduled. Well, in this case, we're going to wait 10 seconds to make sure the container doesn't crash, and then we can start to get traffic. Now, if it does, then it can be rescheduled. So that's kind of a bonus property to mention that we can put in our deployments and our YAML. Now, other than that, we have the selector we've talked about that matches the selector on our template, and we're kind of ready to go. So what I'm going to do is come on into Node app in the terminal, and we're going to get this deployment going. Now, if we do a kubectl get all, you're going to see I don't have anything except for one additional service. Now we're going to talk about services a little bit later in the course, but I've already created a service for this so that we can get to it through the browser. It's very similar to the port forward we did, but a little more official. And we'll talk more about it later. Just kind of know that's working behind the scenes. From here, we want to go ahead and use this Node app v1 deployment. So let's go ahead and get that deployed. All right, so that's been created. Let's do a kgetall again. And you'll notice that the containers are being created as we speak. Now we'll give that a moment and everything should be good. So let's clear it and let's try again. And it looks like they're now running. So I'm going to come over to the web page here. And because I've set up this service, it'll point to the pods and it'll actually load balance across the pods. So we'll go ahead and refresh and you can see node v1. Now an interesting thing here, I'm going to refresh one more time. Notice the ID ends in L4 and notice it stays on that. Well, the reason is load balancing does happen behind the scenes and we'll talk about that more with services. But because it's based on the connection to the server, well, browsers create a single connection. And so it's being smart enough to keep us on that same pod because we're using the same connection. So I just wanted to point that out, something we'll see again as we talk about services. Now let's go on in. We have our v1 running. Let's go ahead and deploy v2. And then we're going to kind of refresh the browser as we're doing this to see what happens during the deployment. All right, we'll let that run. I'm going to refresh. Notice v1 is still running. And we'll give it a sec here because eventually, once these are up, let's do a kgetall and see where we're at. All right, so it's still terminating some of these. But we should now, there we go. v2 is now running. Okay, and then likewise, let's do it again and we'll go to v3. All right, let's refresh again, and this will take just a moment, but we'll give it a sec, and you'll see v3 pop up. All right, and you can see now it's still terminating, try to run some other ones. And there we go. We now have our v3. So what's so great about this is Kubernetes is automatically taking care of bringing up the new pods, as I showed a little bit earlier, but keeping the old pods running as long as necessary until that new pod is ready. Then it can switch the traffic over to that new pod. And that's exactly what's going on. So even though it's doing some cleanup in the background right now, you'll see there was no disruption to the application because it will just replace the different pods as it needs to. Now, the V3 version of this, let's go open that real quick. Looks like this one had 3 replicas. All right, so when we're done here, let's see if everything has stabilized now. And there we go. There's our 3, and then we should still be on V3, obviously, over here in the browser. So that's an example of what a zero downtime deployment looks like, and you can see why this is such a powerful concept. In this module, we've seen how pods are deployed, managed, and scaled using deployments and replica sets. Now, deployments are these higher-level resources that define one or more pod templates, and we know that they use replica sets behind the scenes to actually manage those pods that are running. We also talked about several kubectl commands such as create, apply, and scale. You've seen create and apply quite a bit because they're used in many scenarios. And then learn how we can use those commands to actually get a YAML file, which defines a deployment, out there and running so that our pods are up and running. And then we wrapped up by talking about zero downtime deployments, discussed different alternatives there that are available and supported in Kubernetes, and even walked through a demonstration of switching between multiple versions of an app and showed how that app actually stays up as the different pods are going up and down. So now
Тут давайте зробимо перерву. Перерва буде до 11:15 і почнемо нову підтему.
Recording stopped.
Продовжуємо.
Recording in progress.
Починаємо наступну тему. Наступна тема буде Service Discovery Challenge. Тобто ми закінчили тему, яка стосується Deployment Challenge. І в рамках неї ми подивилися на поди в деплойменті та на поді в Kubernetes і на деплойменти в Kubernetes. Тепер ми рухаємося до Service Discovery Challenge. І тут давайте спочатку цей челендж зрозуміємо, а потім зрозуміємо, як його адресувати. Problem statement. Problem statement, що в нас є сервіс. І ми вже знаємо, що сервіс в одиничному екземплярі не буває, має бути декілька інстансів сервісу. І є клієнт, який хоче той сервіс викликати. Питання, як він зрозуміє, куди взагалі робити виклик, при умові того, що ви вже бачили, що ось ці сервіс-інстанси, вони достатньо динамічні. Вони можуть, може бути апдейт версії, він може просто там впасти, щось там йому поганенько стало, чи, наприклад, його перенесли взагалі там на іншу ноду. Тобто є безліч причин, чому цей інстанс може вмерти. Так от, питання до вас. Як ми можемо взагалі адресувати цю проблему? Думки? Ніяких думок?
Поки ні.
Добре. Значить, насправді є два способи цю проблему адресувати. Перший спосіб – це application level. Тобто ми введемо спеціальний мікросервіс, який нам буде розповідати, хто взагалі, де цей сервіс існує, на яких айпішниках він працює, де ці інстанси знаходяться. Тобто з'явиться ще один мікросервіс, який буде знати про кожний мікросервіс та які інстанси в нього є і де вони знаходяться. І є другий, щоб ми те зробили на рівні інфраструктури, щоб нам все те інфраструктура допомагала розрулювати. Тут я покажу цю картинку. Тобто в інфраструктурі перед подами з'являється ще один елемент, який такий фронтлайн, такий проксік, який розбирається, який знає про які поди саме до цього сервісу відносяться, до нашого мікросервісу, і робить такий роутінг до них. Ось два, тобто, і ось цей елементик, чи інфраструктура його надає, чи ми будемо якось його самі емулювати на application level. Ми розглянемо обидва варіанти, і ми почнемо з application level підходу. Значить, ідея. Давайте, я тут даю дві картинки. Перша картинка – це те, що ми будемо насправді, те, що я вам покажу. Тобто в нас є, ми кажемо application level, спеціальний мікросервіс. В нас є сервіс, який називається Service Registry. Ось ці сервіси, це теж певний мікросервіс. Тобто інстанс А, інстанс Б, інстанс С, але одного мікросервісу. Вони тут, коли вони стартують, вони зареєструються. Коли клієнтику треба викликати сервіс, то він звернеться до сервіс реджестрі і скаже: так, а мені взагалі треба зрозуміти, куди я можу звернутися до сервісу, який мені треба. І сервіс реджестрі скаже: окей, ось тобі масив адрес. І клієнтик вибере там якимось чином адресу і буде робити виклик. Роблю паузу. Що скажете?
Якщо цей мікросервіс реєстрі впаде?
В нього ж теж є декілька інстансів. Він теж має...
Він має якось зберігати ці дані, чи вони будуть якось локально, поки він живе?
Значить, дивіться, тут гарне питання. Якщо в них, зазвичай в них немає сервіс реджестрі, бази даних ніякої немає. Він то зберігає в пам'яті. І тут вже питання того, як той сервіс реджестрі будувати. Тобто, якщо їх є 2, чи 3, то я думаю, що вони просто між собою мають обмінюватися інформацією, щоб кожен мав сліпок своєї інформації, щоб якщо один впаде, то нічого страшного.
Це не може бути як ботлнеком. Технічно, якщо в сервісі всіх стає дуже багато інстансів. Така думка з'явилася.
Якщо дуже багато інстансів сервісів, то чи не вернеться? Слухайте, насправді скільки там, 10, 20 сервісів. Це ж не мільйони.
Теж справедливо.
Угу. До речі, ваші думки. Якщо сервіс, інстанс падає, якось цей сервіс реджестрі може здогадатися, що інстанс впав.
Проби робити?
Так, він має робити певні проби, і якщо сервіс не відповідає, то його... ось це про нього забуде. Насправді тут є декілька. Є 2 техніки, зараз таке втопік трошечки, є 2 техніки, як зрозуміти, давайте я включу відосик. Є 2 техніки, як зрозуміти, ось є одна сторона, є інша. Є, наприклад, сервіс реджестрі робить пробу інстансу, це одна техніка, вона називається така пінг-ехо. Ми щось туди, а назад нам ехо. А є ще інша техніка heartbeat. Тобто інстанс буде казати: я живий, і сервіс реджестрі буде розуміти, що живий. Як тільки heartbeat перестав, то все. Що саме, тобто сервіс реджестрі from scratch, ніхто не пише, вже є готові імплементації насправді. Що там під капотом, яку саме техніку вони використовують, ось цю пінг-ехо, тобто буквально пінг-ехо, чи heartbeat, я не знаю. Але якась з них використовується.
До речі, ще таке ви сказали, що, наприклад, там реєстрі буде якісь там хелс-чеки проводить, чим буде перевіряти, пінгувати. Але ж виходить, що у нас і оркестратор перевіряє, чи інстанси підняті, і реєстрі теж буде перевіряти.
Значить, тобто, знову таки, як саме сервіс реджестрі перевіряє сервіс за допомогою health-чеків, чи за допомогою, тобто health-чек – це ping-echo, чи за допомогою heartbeat, я тут не скажу. Але так, сервіс реджестрі треба розуміти, що інстанс живий. Ось ця вся, тобто, єдине, що в оркестратора задача не просто розуміти, що інстанс живий, а в нього задача підняти інстанс, якщо він впав. У реєстрі такої задачі немає. Йому просто треба розуміти, інстанс живий чи ні. І тут насправді дуже гарне питання, це яке нас веде до того, що чи треба взагалі, щоб це було реалізовано на... Вибачте, хтось незамітаний, там є звук, і мене дуже відволікає. Даніл, мабуть, від вас звук, чи від когось іншого? Дякую. Дякую вам. Так, значить, питання було в тому, що і сервіс реєстрі, і оркестратор мають розуміти, що інстанс живий. Дуже валідне питання, і насправді воно нас підводить до того, чи взагалі нам, воно нас підводить, яким шляхом нам йти. Ось цим application level чи infrastructure level. Просто не всі. Справа в тому, що це буде, тобто Kubernetes теж оркестратор. І якщо, Kubernetes нам дає ось таку сутність. Але якщо нам оркестратор не дає таку сутність, вона нам треба, я пояснила вам чому, то тоді нам треба мікросервіс вводити. Відповіла? If you're talking, you are on mute. Значить, ще розкажу про праву опцію. Вона має місце, але тут, і, мабуть, складніше побудувати. Тут треба більше заморочитися тим, як її побудувати. І тому вона більше така академічна зараз буде. Тобто є певний, я зараз навіть, чесно кажучи, ось технології, мені буде дуже складно її побудувати швидко. Так, взяти різні компоненти, раз зібрати і готово. Тут треба буде заморочитися. Тобто є певний load balancer, виклики йдуть через цей load balancer, load balancer звертається до Service Registry, яка знає, де інстанси знаходяться. Load balancer вибирає, на яку ноду ми підемо, і робить виклик. В цьому випадку, в лівому, у нас буде client-side load balancing, почалося. А в лівому випадку в нас буде client-side load balancing. Тобто клієнт буде вирішувати, куди робити виклик. В цьому випадку ось цей load balancer буде вирішувати. Це такий, server-side load balancing. Нас зараз цікавить ліва опція, і я її покажу вам на практиці. Так, добренько. І демка. Так. Зараз буде демка. Секунду. Що в мене буде? В мене буде Discovery Server, тобто ось, якраз те, що наш елемент, який ми будуємо. В мене буде сервіс, мікросервіс, який буде запущений в двох інстансах. І в мене є клієнт, який робить виклик мікросервіса. Значить, ось цей Discovery Server, я його будувала дуже просто. Зараз покажу вам. В мене є ось це Spring Cloud. Spring Cloud, він побудований дуже багато в чому на результатах, на тому фреймворку, який Netflix для себе багато років назад зробив. Для того, щоб вирішувати саме такого роду проблеми. Тобто, бачите, Netflix ще і технологічна компанія. Це було до того, як Kubernetes з'явився, і до того, як Kubernetes почав завойовувати світ, то багато людей використовували саме ось ці клаудні частинки, які Netflix зробив. Тобто, цей наш Discovery Server, він вже є. Він тут називається Eureka. По-англійськи читається Eureka. Тобто це в мене Spring Boot застосунок, в якому є одна залежність, ну, дві насправді, актуатор, це Health Check, і Eureka. З точки зору коду, це, ну, взагалі тут нема нічого. Тут є аж один клас, і стоїть анотація Enable Eureka Server. Тобто, ну, тут це Spring Boot, і він, коли стартує залежності, то там ті залежності самі автоконфігуруються, бла-бла-бла. Ну, тобто, ми стартували application, в нього embedded Eureka Server виявився. З точки зору, значить, цей Eureka Server, він у нас працює на ось такому порті. Ось, ну, тут сказано, що сам себе Eureka Server не має реєструвати. Ну, типу, ось. Чи реєструвати самого себе. Ну, таке. Так, тобто, окей. Далі в нас є сервіс. Сервіс в мене запущений в двох інстансах зараз, на двох різних портах. З точки зору залежностей, в мене є, це теж просто застосунок, і Spring Boot, і в мене частинка теж Eureka, але це Eureka Client. Якщо там був сервер, то тут клієнт, тобто клієнт Eureka. Далі тут ми маємо вказати, ми розповідаємо, де наша Eureka знаходиться, і розповідаємо, як звуть наш мікросервіс. Ну і на якому порту. В мене він запущений на двох портах, там є порт 8081 і 8082. Ну, треба, до речі, подивитися, на яких портах воно в мене. Так, тут точно 8081, а тут... ні, тут 8080. Вибачайте, обманула. Тобто, ну, просто я його запустила на цьому порті. І в мене є клієнт. Клієнт, він має зробити виклик сервісу. З точки зору залежностей, тут в нас є, ну, насправді нам клієнт в Евріці не треба, ну, up to us, чи реєструвати його чи ні в Евріці. Але от що нам треба, тут багато залежностей, але зараз я не буду вам про них говорити. Зараз вам покажу код. Ну, скажімо так, нам треба оця залежність, і зараз покажу чому. Чи треба реєструватися не факт, тобто чи треба нам оця анотація не факт, але, значить, наш application, і в ньому зараз я звертаю вашу увагу саме на ось цей метод. Тобто наш сервіс буде викликати саме цей. Тобто ми будемо викликати саме цей метод піде на наш інший мікросервіс, ну і зробить його виклик. Значить, тут ми кажемо, ми робимо REST template, ну, тобто ми будемо робити просто REST-виклик. Потім кажемо, клієнт Eureka, а дай мені, тобто Eureka Client – це як ми звертаємося до сервісу, до Eureka і кажемо, ну, тут це назва клієнт, не буду зараз зупинятися на семантиці. Тобто ми звертаємося до Eureka, кажемо, дай, будь ласка, де знаходиться мікросервіс-сервіс. Він нам скаже якийсь, ну, тобто, дай нам, ну, якийсь інстанс. Тобто не всі, а якийсь інстанс. Нам дадуть якийсь інстанс, і ми зробимо на нього виклик. Ну, зрозуміло, що тут багато коду, тут можна оптимізувати, є бібліотеки, де це буде гарніше виглядати, але, ну, зміст зрозумілий. Ми робимо виклик, ну, все дуже straightforward. REST, дайте мені куди, і я зробив виклик. Тепер давайте подивимося на це in action. Значить, в нас є Юріка. Давайте, в нас Юріка працює. Вона працює в нас на порту, я показувала, 8761. Що в нас є в Юріці? Ну, в нас ми клієнт такі зареєстрували в Юріці, і ми зареєстрували сервіс. Але сервіс у нас, бачите, два інстанса 80 і 8081. Окей. А тепер ми хочемо, щоб клієнт викликав сервіс. Ну, пішли. Клієнт. Ось це в нас 8083 – це клієнт. І ми викликаємо endpoint Юріка клієнт. Викликаємо. Ага, він каже hello from port 8081. Тепер, ну, я перегрузила, перевантажила hello from інший порт. Ну, тобто, ви бачите, що туди-сюди нам по раунд-робіну віддають там next instance, якраз 8081, потім 80, ну, так от по черзі нам там віддають. Так, questions. Окей, значить, демку ми зробили, а тепер ми переходимо до Kubernetes. Тобто далі це все з application level. Далі переходимо на infrastructure level. І ми будемо дивитися на Kubernetes саме ось на цю штуку. Ось як саме сервіс організований. Так. Тут скажу... Ні, тут давайте ми краще подивимося тут. Зараз.
So let's talk about some of the core.
Так. Значить, по сервісах вони бувають різні. Не впевнена, що ми сьогодні все закінчимо. Тобто сервіси – це окрема тема, бо сервіси бувають різних типів, і там треба буде вникати в це. Ну, дивимося.
Concepts related to services. So Kubernetes defines a service this way. A service provides a single point of entry for accessing one or more pods. Now, to dive into this more, let's ask a question then. Since pods live and die, can you rely on their IP address? So let's say that we have an external caller, and that calls into a front-end pod with an IP address and a container, and then that calls some back-end pod. Well, what if one of those IP addresses changes because the pod actually goes down and has to be replaced? So the answer, of course, to this question is no, we can't rely on an IP address of a pod. That's why we need services. IP addresses change a lot as pods change. So when it comes to the life of a pod, we know that pods are mortal, if you will, and they may only live a short time. They're ephemeral, we could say. Now, of course, that depends on the pod. You could have pods that stay around for a long time, but you just never know. So you can't rely on a pod IP address staying the same, because if that pod gets rescheduled and comes up as a new pod, it's going to get a different IP address more than likely. We also know that pods can be horizontally scaled, so as that happens, of course, a new IP address would have to be issued to that new pod. And another important thing to know about IP addresses and pods is that a pod only gets its IP address after it has been scheduled. So there wouldn't be a way for a client to know about that IP address in advance. Therefore, we need a better way to work with these, and that answer, of course, is services. The goal in life of a service is to abstract that pod IP address from consumers. So if you take a look at the left-hand image here, we have the service at a fixed IP, but then it's going to know how to talk to the pods behind it. Now you'll notice the yellow labels there, My App. We talked about labels a little bit earlier in a few other modules of the course. Labels are really, really important here because they're going to be used to associate pods with a service. Now, as that service comes up, we can rely on that IP address, but the behind-the-scenes workings of the IPs of the pods, that's going to be handled by the service. So if a pod dies and a new one comes up, the service will know that IP, and it's going to know how to load balance between those pods, which is a built-in feature. Now, as mentioned, it does rely on labels to hook up the service and the pods. So we're going to see that again as we move along. And earlier in the course, when we talked about the big picture of Kubernetes, we saw that worker nodes have a kube proxy, and that's what creates a virtual IP for the different services that are running. Now, this uses layer 4, which is TCP/IP. Services are not ephemeral, meaning they're not short-lived. They stick around. Pods can be ephemeral, but services, we need to have them sticking around because that is the thing that a client on the outside world or another machine, a worker node, would know about. Now, what services do behind the scenes is create something called endpoints, and that's what sits between that service and the actual running pod. So to look at this a little more visually, if we had an external caller that's calling into Kubernetes, then we would need to have some type of service they can call. Now, that service would know about the pods that are behind it, and it would deal with the IP addresses for those pods. Notice that the service and the two pods here have front end as their label. That's kind of the magic that hooks all this together. Now, these pods might talk to some other set of pods, and that would be done through a service. And in this case, we have backend as our label that would be tying the service to the pod that you see. So you can see that services play a really, really important role with Kubernetes. I mentioned that services do pod load balancing. So if a service is tied to multiple pods that have been replicated, then that service can load balance between these based upon the connection that's coming in. So for example, if an external caller calls in, then the first pod here might get it. Then another call comes in. This second pod might get it, and so on and so forth. And this is what it'll do behind the scenes for you. Now with browsers, it's a little bit unique, and I actually showed you a sneak peek of this when we talked about deployments. What will happen with browsers is because they use the same connection over and over and over for the request to the server, that will be respected by Kubernetes, and that one connection would keep hitting the same pod. Of course, if that pod goes away, then that can be rescheduled, and the service can then deal with that. Now let's wrap up this core concept discussion with a little caveat. There's a lot to networking in Kubernetes. We're going to touch just on the core concepts because as a developer, you definitely need to know these basics. So the goal of this module is to kind of break in gently to how services work, how you can create them, different service types. But keep in mind there's a lot more, and there's some other courses on Pluralsight that dive much, much deeper into networking. Now, having said that, let's keep moving on, and let's talk about the different service types that are available in Kubernetes. To work with services in Kubernetes, you need to know about the different service types, and that's what we're going to talk about in this section. So when it comes to service types, there's four main types. We have the default type, which is called a cluster IP, and this makes it so that a service can talk to internal IP addresses and set those up for your pods. We also have one called node port, and this is where we'll have the IP address for a node and then set up a static port on that node that we can call into. We can also have a load balancer. Now this would sit in front of our different nodes and then provision an external IP to act as that load balancer to call into the nodes and then ultimately call into the pods. And finally, we can have an external name service that maps a service to a DNS name or IP address. So let's dive into a little more detail about these different types of services. So the first one, cluster IP, is the default as mentioned, and this exposes an IP address internally within the cluster. Now what this will do is you'll have a service that's set up, and we know that service can then talk to the different pods. But the service itself is just going to be used internally within the cluster. So only pods within the cluster can talk to that service, but it does allow pods to talk to other pods. So for example, in our cluster, we might have a service with these two pods, and those pods now need to talk to this other service you see. A cluster IP would enable this type of scenario, and so this is very common, of course, because the external world oftentimes only needs to talk to maybe one or two services, let's say. But behind the scenes, we might have a ton of services with their associated pods that we then talk to. Now, the next type of service is a node port service. This exposes the service at the worker node's IP, and it's going to have a static port assigned. Now, this will automatically allocate a port by default, although you can override that, and you can see the range here. And what will happen is that service will then make it so that we can proxy through that node into the pods behind the scenes. So it looks like this. Let's say we have a node, and we've exposed a node port service on port 30,100 that you can see here. Now, behind the scenes, we also have these pods that we want to talk to. So with a node port service, an external caller can now call into the IP address of the node and that port, 30,100 in this case. Then that can talk to the behind the scenes services that are set up and the pods and everything else that we might have. And that's what a node port service does. So this one's actually very, very useful for a few reasons. Number one, we could set this up so an external caller could call in, and that's useful. But as a developer, oftentimes we might want to run some type of an external call for a debugging purpose or maybe performance reasons. So knowing how we can proxy into a given pod using a node port service is actually really, really valuable. And we'll see more of this as we move along throughout this module. Now, the last one is a load balancer. Now, you've probably heard of or maybe even implemented load balancers at your company. Load balancers, of course, are important because as a call comes in, some nodes are busier than others, and we might want to route to different nodes based on the traffic. So a load balancer service exposes a service externally, and it's really useful when combined with a cloud provider's load balancer. So whether you're going to Azure or GCP or AWS or some other cloud, they will definitely have their own type of load balancer. And then Kubernetes has its own type as well. In fact, it has several you could use. There's an Nginx one, there's the default one that I'll show you, and others even that are available. So what will happen here then is behind the scenes, we'll have node ports on the nodes that would be set up for us by this type of service. And then internally on those nodes, we know we have cluster IP services as well. So that would allow the outside world to call in. Each node then, once it gets called, is going to proxy that into the internal cluster IP services. Now, if a new request comes in, that might load balance to a different worker node, and then that would call into other services behind the scenes. So you can see it's kind of a combination of all of these. We still have cluster IP services behind the scenes, but then we also have a node port type service on the nodes that are set up, and then the load balancer service itself will know how to talk to those. Now, the final type of service we're going to look at is called an external name service. So this sets up a service that really is just an alias. So we know a service sticks around and we can count on a service's IP address, but what if really what we're after is we want to call some other domain, maybe within the company, maybe outside of the company, who knows, or IP address. But let's say that domain or IP keeps changing on us, and we now have to keep updating the containers in the pods that want to talk to it. Well, this would allow us to define a service once that can then proxy requests to this external service. And that way, if the external service DNS or IP address changes, we could just update this service. That way, our clients stay unaffected. So in essence, the external service is just hiding the details from the actual cluster of what we're actually calling out to externally. So it looks like this. We might have a service internally, which is maybe just a cluster IP service, but then these pods might call an external name service. Now, of course, that acts as really just a proxy between some external service out there. As mentioned, if that external service changes, we just update the external name service, and we don't have to impact all the other pods and internals that are calling that service. So that's a look at the main types of Kubernetes services. So now let's take a look at how we can actually work with services and kubectl.
Тут давайте трошечки зупинимося, бо ці типи сервісів, давайте на них зупинимося, вони можуть бути трошечки заморочливими. Так, зараз буду скролити назад. Значить, в нас був, так, це, ось, кластер IP-сервіс. Хто як його зрозумів?
Це просто як певна обгортка для кластерів подів, щоб у нас не под з подом спілкувався, а под сервісом.
Да, ну я маю на увазі, що сервіс типу кластер IP. Тобто в нас для цього, тут є один use case. Ось в нас є сервіс, він закриває там один чи декілька подів, але use case – це для випадку, коли в нас мікросервіси спілкуються тільки всередині кластеру. Тобто один мікросервіс всередині кластеру викликає інший мікросервіс. І тому нам достатньо цього кластера IP. Тобто усі поди мікросервіса ми можемо дістати, по суті, по одному всередині кластера. Деталі тут не важливі. Це кластер IP-адрес. Наступний кейс – ось це node port. Хто як його зрозумів? Тут node – це машинка, де поди знаходяться. І це, тобто сервіс – це сутність кубернетеса, і цьому сервісу дається порт, який пов'язаний з портом саме ноди. Тобто ви можете буквально до фізичної машинки, чи до віртуальної машинки, якщо ви знаєте її адресу, то ви можете на цей порт цієї машинки законектитися, і тим самим ви законектитеся до цього сервісу і можете викликати ці поди. Так, окей? Це більше, тобто це не продакшн сценарій, це більше такий, я б сказала, дебагінг сценарій. Коли, якщо вам треба там дістатися, зробити виклик в кластері, пода, який, в общем, давайте так, це не продакшн сценарій. Наступний ще сценарій. Так, давайте. Це сценарій він буде більше пов'язаний, тобто якщо ви хочете, щоб викликати ваш сервіс ззовні, якщо ви хочете викликати ваш сервіс ззовні, то тоді вам знадобиться ось такий, тобто тут така прям комбінація. Тобто це load balancer. Це load balancer сервіс, але він насправді, тобто тут прям комбінація виходить, що є load balancer сервіс, але він під капотом звертається там до цих ось node port сервісів. А use case вам треба робити насправді external виклики. Вам треба дати там фронтіку можливість конектитися, наприклад, до беку. Оце воно. Я скажу, що ми не будемо використовувати load balancer сервіси, ми будемо використовувати інгреси. Тому вам не прийдеться load balancer сервіс конфігурувати руками. Вони є, але ми їх конфігурувати не будемо. Так, і є ще external name, тут такий більше, я б сказала, такий синтаксичний цукор. Якщо у вас є, вам треба викликати external сервіс, тоді Ну, це такий от сервіс, ось цей сервіс, external name, за ним подів немає, а він просто робить виклик. Ну, це для інтеграції з зовнішніми системами. Окей, давайте, мабуть, на цьому ми зупинимося. Зупиняю запис. Чи є питання?
Це от external name. Це просто як для нетворкінгу, чи він ще може якось дані процесити?
Дайте більше, поясніть більше питання.
Наприклад, якщо external сервіс, він просить певний формат даних, коди видають інший, і нам потрібно десь це конфігурувати.
Ні, я думаю, що це тільки це такий синтаксичний цукор для нетворкінгу, щоб ви не прописували, ну, щоб ваш код не був залежний від адреси екстреного сервісу.
Зрозуміло, логічно.
Да. Угу. Окей.
Recording stopped.
Тоді дякую вам, це все на сьогодні. Спокійного дня і побачимося через тиждень.
До побачення.
Да, гарного дня.
Дякую, до побачення.
До побачення.
Дякую.